My name's Heidi Sauerlein. I'm the program coordinator with the Indian River Lakes Conservancy. So without further ado, we are going to share with you today the power of native plants and how you can harness that power right in your own backyard. You will learn why choosing to grow native plants rather than non-native or invasive species is so important. What to avoid growing, how to attract pollinators in your yard. Plus, you can also learn how to aid in a statewide pollinator community science project. So there will be opportunity to ask questions today. You can do this multiple ways. So you can use the chat box. If you were on earlier, you probably heard my explanation, but if you're on a desktop, at the very bottom, you can hit the little bubble, speaking bubble, and that will bring up a chat box on the right-hand side. Before you ask your question, just type your name in the box and then your question. You can also do what's called raising your hand, and then I'll unmute you and you can ask your question. So you can do either of those two ways. If you're on a phone, it's a little different. You have to go to the bottom right-hand corner and do the 3 dots to get to your chat. So enough housekeeping. So I'd like to welcome Megan Pistolisi with the St. Lawrence Eastern Lake Ontario Partnership for Regional Invasive Species Management, also known as FLELO PRISM. Megan is going to discuss the impacts of invasive species and the power of natives. So go ahead, Megan.
Hello, everybody can hear me now. Thank you, Heidi. Welcome, everybody. So I'd like to begin my talk by explaining what an invasive species is. So an invasive species is any plant, animal, or even a microorganism like a virus that causes harm to our environment, our economy, or our health. The term invasive species can be easily confused as there are many non-native species that are not considered to be invasive. For example, apples and many other agricultural crops are non-native species that are considered beneficial to our culture rather than harmful. There are also species that are considered to be a nuisance but are not invasive, like dandelions, for example. You may wonder why some non-natives are so invasive. This is because when a species is introduced to a new environment different than where they originated from, they entered that new area often free from environmental factors that keep their populations in balance, like natural predators or parasites. In addition, invasives also often produce many offspring or seeds. For example, one adult purple loosestrife plant can produce over 2 million seeds annually. Because of this, invasive populations often become widespread. The bottom picture here shows invasive common reed or Phragmites filling an entire field with a single shrub existing in the mass. In addition to lacking natural predators, invasive species also have attributes that allow them to thrive in environments that other species may not do so well in, such as poor soil conditions. Pictured in the top right shows invasive Japanese knotweed growing right out of a hole in concrete. So if invasives are so bad for the environment, then why are they here to begin with? Many plants that are invasive were once considered desired ornamentals that were often intentionally introduced to our country. For example, pictured here is Japanese honeysuckle, an invasive plant that was often intentionally planted by gardeners to beautify their lawns or by highway designers to control erosion or stabilize banks. However, over time, non-natives often misbehave and escape our gardens and invade other natural areas where they outcompete our native and desirable plant species and damage entire ecosystems. There are many specialized relationships that exist between plants, birds, and pollinators that are disrupted by invasive species. For example, black and pale swallowwort are invasive vining perennials that outcompete native common milkweed. Milkweed is the preferred host of the larva for monarch butterflies. Furthermore, studies have learned that when monarchs lay their eggs on these invasive swallowworts, the larvae die. There is power in planting native species. Native plants support our native wildlife. This is because native plants have co-evolved with native wildlife and insects. Native birds like the chickadee rely on caterpillars to rear their young, and native plants support caterpillars. We will go into greater detail about what native plants to grow in your yard to support these specialized relationships later. If you choose to grow native plants in your yard, you're choosing to support pollinators and are helping to stop the spread of invasives. SLELO Prism and the Jefferson County Cornell Cooperative Extension are encouraging gardeners in our region to choose to grow native plants. We've created a brochure showcasing a variety of easy to grow native plants, and we will email each of you a digital copy of this brochure along with other resources. I'd also like to mention that SLELO is hosting a webinar tomorrow between 1 and 2 about an invasive Asian jumping worm that gardeners should keep an eye out for, and you can register for this webinar right on our website at sleloinvasives.org/events.
Okay, so today we're going to talk about how to attract pollinators to your garden. Is everybody seeing a screen with a PowerPoint presentation on it?
Gotcha.
Great, okay. So this is from the Xerces Society. They are an organization that works with pollinators, our native bees, our pollinators, and some of the pollinators that aren't quite as flashy as we would want or expect. But according to the Xerces Society, native bees and native pollinators are in decline, and this is because of us. We've done that. We use a lot of pesticides, we've fragmented habitats, and habitats have been lost and degraded. And as a result, we're losing a lot of our, not only our native pollinators, but insects in general. Pollinators are keystone species, and this is why we need to encourage them. A large number of other species depend on them for survival. If you have abundant pollinators in your ecosystem, this is indicative of a healthy ecosystem. We need pollinators because pollination creates a seed, and that perpetuates the species. 80% of all flowering plants need a pollinator. In fact, it's been said that every 4th bite of food that we take requires pollination. And without pollinators, we would not have any of these fruits and vegetables that are on the screen. And there are literally hundreds and hundreds more that require pollination. These are just some headlines I took off the internet. In China, they have had some serious problems with pollination, and they've lost a lot of their pollinators. And as a result, they have to hand pollinate their apple trees. So here in the picture on the left, we have a gentleman with a wand, and it's got a little brush on the end, and people have to climb up in trees and actually pollinate by hand. We don't want to see this happen. Can you imagine what the price of apples would be if apple trees needed to be hand pollinated? So this is something we don't want to see. So when the pollinators disappear, we get into a downward spiral. Native plants then disappear, invasive plants move in, and birds and animals move out. So you end up with kind of like an ecological desert. So what can you do to support pollinators? What can you, right in your own backyard, do? You don't need to have a large amount of property. You don't need to have fields. You can just encourage pollinators simply by putting out a pot of flowers. That's the simplest thing you can do, and that is beneficial. So don't think that you have to grow acres and acres of meadows and flowers. It's not necessary. Even little things help. So we're going to move into some of the things you can do to support pollinators. The number one thing, and this is supposed to be animated so you could see these slides, but in the picture on the right, that is a Norway maple. And Norway maple is an invasive species. It is regulated now. You can no longer buy it. But if you have one of those maples in your yard that is red all year long, like a Crimson King maple, that is a Norway maple, and you are harboring an invasive species. Now, nobody's going to make you cut that tree down, but you should not take any of those little seedlings and transplant them. Norway maple outcompetes our native maples. So if you have the desire to have a tree similar to the Norway maple, go with some of our native species, red or sugar maple or red oak. You will get red leaves in the fall, but you will not get them year round. And that's the appeal of the Norway maple, especially the red variety. People like this cool looking tree with red leaves, but it is invasive. Winter creeper, which is a type of euonymus, is invasive. That is now regulated. A good replacement for that are ferns. Japanese barberry is also regulated, although you can still buy it. Apparently there are landscape species that have been bred to not produce any seeds, so it's less invasive. So if you really have to have a Japanese barberry, make sure you get the type that does not produce seeds. Better than that would be to plant some of our native species like chokeberry or ninebark. They're very similar to Japanese barberry. And another favorite that people have in their yards is burning bush. Everybody likes that fiery red color in the fall. Again, this is another invasive that we find moving into natural areas. Good replacements are dogwood and chokeberry. Yes, Steve has just put in a red leaf cultivar of ninebark, which ninebark you can get in like copper colored leaves, red colored leaves. There's all different cultivars. So if you desire that reddish shade like the Japanese barberry has, ninebark will give you lots of options. Another one that has been overplanted and is very much problematic is the Bradford pear. I wish you could see the picture on the right, but if you go through certain areas this time of year, Bradford pears are in full bloom, and they are beautiful trees, but they are extremely invasive. They were overplanted. And what we found is that they are not a good tree to plant. They're messy, they tend to break up in storms, and they smell really, really bad. In some cities where they've planted Bradford pear, populations complain when they are in flower because they smell so nasty. So good replacements for Bradford pear are crabapple, serviceberry. If you have a Russian or autumn olive, or you desire that kind of grayish green willow type look to a leaf, good replacements are staghorn sumac or hazelnut. And then Megan mentioned the Asian honeysuckles that have been just planted everywhere. We thought they were a good thing, and about 30 years later, we found out they weren't so good. So our native dogwoods are excellent replacements. And then if you can see in the picture around that X on the top, that is bishop's weed. Bishop's weed is a perennial plant that they planted around their foundations, and it has these variegated leaves. But after a few years, unfortunately, the plant reverts to its species form, and the leaves become completely green, no variegation, and it becomes very, very invasive. It is a nasty plant. People who have this know what I'm talking about. If you try to dig it up, the roots are like spaghetti. So good replacements for that are golden Alexanders, which look like a yellow Queen Anne's lace, so to speak, and Canada anemone. All of these replacements are native species. So avoid the invasives and then favor native plants. Native plants are adapted to our soil and climate conditions. They have fewer disease and insect problems, so they just do much better in our environment. They're also well behaved. Very few native plants become invasive. And if you have a healthy population of native plants, it's going to prevent invasives from moving into an area. As you favor native plants, we encourage you to do this because our native insects, birds, and plants have all evolved together. And over millions of years of evolution, interactions and things have taken place where these plants and animals know how to use each other. So when you plant a native species, you're adding something that contributes to the ecosystem. It's something that native insects and birds recognize, and they can use it for food and shelter. A lot of times if you put in a non-native plant, it really doesn't add too much because it doesn't fit in the ecosystem and the insects and birds do not know how to use it. So in general, non-native plants provide less support to our native pollinators. Another reason to favor native plants is because native plants attract native insects, and this is going to attract native birds. So whether you want different kinds of caterpillars, which will result in butterflies and moths, if you like birds, it's good to have native plants because you will attract all of those things. Oh, go back, Megan, please. 90% of all songbirds raise their young on caterpillars that feed on native plants. Caterpillars are very specific as per what they eat, and we'll talk about this coming up in the next slide, I think, or shortly hereafter. You can go to the next slide, Megan. Yeah, okay, so here we go. Caterpillars are basically eating machines, and they're very specific as per what they will feed on. And they obviously need to feed on native species. Caterpillar, adult moths and butterflies will lay their eggs on food plants. When the caterpillars hatch out of the eggs, those food plants are right there for them to feed on. And caterpillars, like I said, don't just eat any green plant. They are very specific, sometimes down to families or genus of plants as per what they will eat. And if you have these food plants that the caterpillars need to eat, you will then have the adult butterflies and moths, some of which will get eaten by songbirds and therefore sustain the songbird populations. Songbirds like to give their young caterpillars. It's an important source of protein. It's a nice piece of juicy thing of insect material. They do not feed their young berries and seeds. They feed them caterpillars. So we always get the question, what is native? And the rule of thumb is anything that's native are things that were here before colonization. So basically before 1600. And there's a lot of debate on that because Native Americans moved stuff around. They made changes in the ecosystem, you know, over thousands of years. Tomatoes and corn were brought up from South America. So you can debate this, but for most books, they use 1600 as the time marker. And you can go to a lot of different books, find out what's native and what isn't. The Native Plants of New York by Don Leopold is an excellent book. The Audubon Field Guides will tell you if things are native. And you can also go online to the New York Flora Atlas. Just Google New York Flora Atlas, and you can type in the common name, or if you know the scientific name, you can use that too. But either way, it will tell you if a plant is native or not. Now, there are many non-natives and less desirable plants that also support pollinators. Many of the weeds and ornamentals that were introduced to this country are used as food plants. So some of those things that caterpillars like to eat are actually non-natives. And anything with a flower that contains nectar or pollen is going to support adult pollinators. So don't get too hung up on making sure everything is native. I mean, we've all got stuff in our yards that's not native. You know, we don't expect anybody to tear things out. But in the future, try to favor native species, be more concerned about things that are invasive rather than things that are non-native. And there is some idea in the landscaping world that we don't even have a native environment anymore. This is especially true for people who live in urban or suburban areas. That environment has been so changed from its original state that if you put native plants in it, they may not do as well because the environment has been so changed from the environment that those plants evolved in. So basically, don't get hung up on things that are not native as long as they're not invasive. So number 3 is to think in terms of diversity. Plant different plant families, plant a combination of trees, shrubs, vines, and perennials, get different flower shapes and different flower colors. Even plants that are considered boring, lowly, weedy, non-native, and annoying have a role to play in the environment. And in the next slide, we're going to go through some of these, popular butterfly and moth species and what they are attracted to. So we're going to talk in terms of food plants, okay? Adult butterflies and moths, they will get nectar and water. They don't eat plants. The food plants are needed in the larval stage. So the larvae of the eastern tiger swallowtail, they prefer to feed on cherry and ash. Cherry and ash are everywhere. You probably already have them in your yard or nearby. The black swallowtail larva like anything in the carrot family. So this includes things like dill and parsley. Queen Anne's lace, which is not native, is in the carrot family. The clouded sulfur prefers legumes. So anything in that leguminous family, alfalfa, clover, vetch, and a lot of these, especially vetch, is considered a weed. And clover is considered a weed of lawn. We threw out clover from lawns about 30 years ago, and it's a very good species for pollinators. But fertilizer companies, lawn care companies told us that clover is bad. You shouldn't have it in your lawns. So you need to use lots of chemicals and fertilizers to get rid of clover when actually it's a very important species. And by the way, none of the clovers in this country that grow in this country are native to the US. They're all from Europe. The spring azure is attractive to dogwood and viburnum. And I'm just reading, Heidi says she has a wonderful amount of clover in her yard. So do I. I don't care, I love it. Okay, you can go to the next slide, Megan. Some more diversity. The silvery blue likes legumes, which include vetch. Morning cloak, which is one of the first adult butterflies that we see in the spring, prefers willow, poplar, elm, hackberry, and birch. And think about this. Poplar is kind of considered to be a trash tree, but yet it supports one of our important pollinators. Poplars are native, but they're just considered to be weak-wooded trees, not long-lived. The red admiral prefers nettles. Nettles are annoying. They are a nuisance plant. If you've ever gotten into them, you know what they're all about. But they do attract the red admiral caterpillars. Painted ladies are attracted to 2 weeds, burdock and thistle. If you have any marginal areas on your property, you probably have both of these growing. The silvery checker spot likes anything in the sunflower family. The Baltimore larvae prefer turtle heads, which grow well in wet areas. The white admiral prefers willow, aspen, and that lowly poplar again. And then the northern pearly eye prefers grasses. Now we get into some of these really cool large moths that are so impressive to a lot of people. The Cecropia moth larva likes all of these species. Box elder is considered to be a trash tree. It's in the maple family, but it's a small, weak-wooded tree. A lot of people take them out. Lilac, not native, but it is attractive to the Cecropia moth larva. The Polyphemus moth, anything in the rose, birch, or willow family. The Luna moth prefers birch, hickory, and walnut. And I'm sure some of you are familiar with a hummingbird clearwing moth. A lot of people think it actually is a hummingbird when they see it flying around. It is attractive. It is attracted to our native viburnums. So as you can see, there's a lot of diversity here. There's a lot of species that we would consider unworthy to have in our yard. There are a lot of species that are considered weeds. There are several species that are not native. And then there are all of our native trees, which are very important food plants for pollinators. So when you think in terms of pollinators, don't just think in terms of flowers. A lot of our native tree species are necessary food plants for the larvae of caterpillars and moths. So if you have plant diversity, you're going to have pollinator diversity. And at the beginning, Megan talked about a pamphlet that you can have access to. And the pamphlet was put together to encourage people to not only plant native species, but to encourage people to plant pollinator species. And these are some of the trees we suggest. Now, this pamphlet is not the be-all and the end-all. The species listed in that are there because they are easy to grow and they have somewhat of deer resistance to them. They're all native. So birch, hawthorn, serviceberry, cherry, poplar, these are all important food plants. And what's nice about birch trees is a lot of species of birch have exfoliating bark. And this is a good place for egg laying. It's a good place to overwinter, a place to pupate. So that provides shelter for a lot of our pollinating species. Evergreen trees are good, not necessarily as food plants, but as shelter because they're often very dense. So eastern red cedar, or sometimes known as juniper, northern red cedar, also known as arborvitae, pine and spruce, all provide shelter for pollinating insects. Some of our native shrubs are dogwood, and this is a picture of dogwood on the right here. This is the red twig dogwood. Looks very nice in the winter against the snow. Chokeberry has edible berries, edible for people, as do currant and gooseberry. There's ninebark again, which comes in different cultivars with copper-colored leaves. Elderberries, raspberries, and blackberries, also all edible plants for people. And our willow species, which basically are the shrub-type willows. We're not talking about weeping willow here, we're talking about the small shrub willows. And a good vine that's attractive as a food plant to a lot of pollinators is Virginia creeper. There is a caveat to this though. Virginia creeper can be invasive. So if you're going to plant it in an area where you can mow around the circumference of it because it does tend to sucker a lot. But as long as it's in an area where it's mowed, it shouldn't create a problem. So probably what a lot of you here are here for are the flowers. And here is a list of some of the perennial wildflowers that we recommend that are easy to grow and attractive to pollinators. So sunflowers, obviously the milkweed family is very attractive to monarch butterflies. Bee balm, purple coneflower, black-eyed Susan, you're all probably familiar with all of those. Meadowsweet is actually a native spirea. This is not the spirea that you have growing in your front yard. You know, it's about 6 foot tall and has arching branches on it. This is a perennial flowering plant. Cardinal flower. This is a good plant for wet areas, and it has a different shaped flower. The flowers are long and tubular, so they are going to attract insects with mouth parts that can reach to the bottom of those tubular flowers and get nectar. The same thing goes for columbine. Columbine, you can't see it in this picture, but at the end of the flowers, there are spurs that contain nectar. And then Joe Pye weed is another good one, good for wet areas, gets about 5 feet tall. Another good species is goldenrod, and a lot of people are afraid of goldenrod. You can go to the next slide, Megan. This is a goldenrod that we grew right in front of our cooperative extension office. This is beautiful. And in the summertime, if you go out there, it's audible. The pollinators that are going after this there's just an audible buzz in the air. Many people are afraid of goldenrod because they think it causes seasonal allergies. It does not. Goldenrod is specifically insect pollinated, so it does not push pollen out into the air. The cause of the seasonal allergies is a plant that flowers at the same time as goldenrod, and that is ragweed. Ragweed is wind pollinated. It's very inconspicuous, very boring, but that's the one that's causing your seasonal allergies in late summer. It's not goldenrod. Goldenrod just gets a bad rap because it's so beautiful and everybody sees it and thinks that's the problem. So another thing you can do is to plant flowers and plant families that have shapes that are especially attractive to pollinators. So there's two families. There's the carrot family and the daisy family. The carrot family are things like parsley, celery, dill, coriander, and they have what's called an umbel-shaped flower head. It's basically an upside down umbrella. This here, the one on the left is dill, the white flowered one is coriander or cilantro in the leaf form. Flowers in the daisy family that have what's called a composite flower head. So you've got this little button in the center and these ray flowers around the outside. So sunflowers, asters, marigolds. This is our native New York aster on the bottom. These shapes tend to be very attractive to pollinators. So there are a lot of ways you can use flowers for the most benefit. Again, go for diversity. Have at least 15 different flowering species. Now 15 may seem like a lot, but you have to remember that of that 15, a lot of these are going to be trees and shrubs that are probably already in existence on your property. Trees and shrubs flower. They may not be very showy or conspicuous about it, but they do have flowers. And again, they're important food plants for caterpillars. Plan for successional blooming. Have flowers and food available when insects are active. And that insects generally, the threshold for most insects is about 50 degrees. Once you get higher than 50 degrees, insects tend to become active. So if you basically have something in bloom from May through October, you're going to support pollinators. Plant flowers in groups. This is kind of obvious. Not only does it look better from a landscape point of view, but insects can actually see groups of flowers better. And we encourage you to use species plants instead of hybrids. Hybrids are plants that have been bred for certain characteristics that are desirable to people. Could be large size, could be certain color, could be disease resistance. It could be a lot of things. And hybrids are not necessarily bad, but in the world of pollination, they can be bad. Because what happens is a lot of times when we create hybrids, we breed the male parts out, which contain the pollen. So an insect will recognize the flower as something that has pollen, and they will go to that flower and waste a lot of energy trying to find pollen that's not there. There's also a very popular thing now is double flowers. Everybody, no matter what you're growing, you got to have those double flowers, big, tightly packed flower heads with lots of petals. And the problem with these is that the petals are so tightly packed that insects can't get at the nectar or pollen if there is any. So again, they waste a lot of energy foraging on these flowers with no return. So if you want to attract butterflies in general, they like long tubular flowers in red, orange, and yellow. So butterflies basically like the hot colors. If you want to attract some of those large moths that I showed you, the Cecropia moth and the Luna moth, they like night blooming flowers like Jimson weed and evening primrose. And bees technically cannot see red. They are more attracted to blue flowers. So if you want to support the bee population, they're going to be more attracted to blue flowers. It doesn't mean they won't go to other flowers. They can just see the blue ones better. So consider the habitat. It's been said that in the United States, we grow lawns. Lawns are the crop of choice in the United States. Far greater than corn or soybeans or anything is turf grass. That's what we grow in the United States. And turf grass is a monoculture. There's no diversity. You're putting a lot of time and energy into sustaining one species. Chemicals, gasoline, time with mowing, pesticides. And monocultures are very difficult to maintain because Mother Nature doesn't create monocultures. Mother Nature is very diverse. So as you're trying to maintain that Kentucky bluegrass lawn, it's really not offering anything to the environment. We cut it off before it goes to seed. There are no flowers. So there's been a trend in this country to have less lawn, mow less, let Mother Nature take over some of this previously mowed property. And Mother Nature does a good job. If there are areas, marginal areas that you haven't mowed them in a while, you know that Mother Nature moves in very quickly. You have to make sure that native species aren't moving in and get rid of those. But every piece of land in the eastern United States, in the northeastern United States, I should say, wants to become a deciduous hardwood forest. And that's what Mother Nature will eventually do. So if you leave things alone, Mother Nature will take care of things. In some municipalities, if you don't mow your lawn, somebody's going to be knocking on your door telling you to mow your lawn. But in some more forward-thinking areas, a lot of people are being allowed to create meadows in their front yards and grow vegetables in their front yards. And that's a good thing. Pollinators need freedom from pesticides. When you have some aphids feeding on your pepper plants and you spray an insecticide to kill those aphids, that insecticide just doesn't go out there and say, okay, I'm going to kill the aphids, and it doesn't target those specifically. It's going to kill any insect it comes in contact with. Insecticides are not selective. So when you use these products, you're killing beneficial insects in addition to the nasty ones that you want to get out of your garden. Water is good to have. Every living thing needs water. Butterflies like puddles. There's a lot of different ways to create puddles within a garden. Put stones that maybe have a little dip in them, a little area that holds water, saucers, things like that. And provide nesting habitats. It's hard for us Americans to do, but if we can just let a portion of our garden become messy, a portion of our yard, where maybe you've got some logs that have fallen, some fallen trees, some snags, unkept areas, leaves on the ground. These are perfect habitats for a lot of insects. Cleanliness is not good as far as Mother Nature is concerned. Those trees with loose bark are excellent, like we said, for overwintering and egg laying sites. And we also like to have a little bit of bare soil for ground nesting bees. And I'm going to talk, probably, now a lot of you are probably saying, oh no, I don't want any ground nesting bees on my property. But I'm going to talk about these a little bit later, and you'll find out that they aren't the evil things that you're thinking of. So that brings us to considering the less flashy pollinators. You know, most of you are probably out there and you know that you should support bees and you like seeing the butterflies, but pollinators go way beyond bees and butterflies. In fact, butterflies and moths are actually poor pollinators. They don't really do that good of a job. So when you think of pollinators, don't just think of honeybees and butterflies. Let's talk about some other bees. First of all, honeybees are not native. Honeybees were brought over here by the Europeans when they came to this country for honey and for pollination services. They're okay pollinators, but there are other species that are a lot better. Our native solitary bees are very important pollinators. And these are those ground nesting and wood nesting bees that I talked about earlier. They do not live in colonies. These are not the ground nesting yellow jackets that fly up your pant legs when you drive over them with the lawnmower. These are solitary bees. They lay eggs individually in the soil. You make little holes, they lay an egg, move on, lay another egg. So they aren't aggressive, and these are the bees that we really need to support. Our other native bees are bumblebees. And bumblebees are really good pollinators. For one thing, they have long tongues, and that allows them to pollinate flowers that are deeper, more tubular, have more complex shapes. They are also generalists, so they'll visit a variety of different plant species, including our native wildflowers and our food plants. Bumblebees can thermoregulate, which means they can shiver. They actually have muscles in their shoulders, and they can shiver to create heat. Therefore, bumblebees can get out and forage at temperatures lower than 50 degrees. So when honeybees and other pollinators aren't out there because the weather's cold and cloudy, the bumblebees are able to get out and provide those pollination services. Another thing bumblebees do is called buzz pollination. If you're ever able to observe a bumblebee on a flower, watch it for a few minutes. It will land on the flower, then all of a sudden it will buzz and shake about. And what it's doing is it's shaking the pollen loose from the flower. And as a result, that just results in better pollination for that plant species. Flies are also important pollinators. These two pictures are actually flies. They are what are called bee mimics. They, the one on the right looks like a bumblebee. The one on the left looks like some sort of wasp, but they are excellent pollinators. And another group of pollinators that is excellent is in the next slide. And these are some of our native beetles. There are flower beetles, there are wood-boring beetles, pollen beetles, even fireflies are good pollinators. And I think in the next presentation, Matt is going to talk a little bit more about this and go into a lot more detail about some projects they're doing with some of these lesser known, less famous type pollinators. So the bottom line, diversify, nurture what you have. Even if you have what you consider to be a lousy box elder tree or a lousy poplar tree, nurture it. It's adding something to the environment. Eliminate invasive species. Don't plant anything. Don't move anything around that could be invasive. Provide a pollinator-friendly habitat, not just for bees and butterflies, but for all pollinators. Don't use pesticides and favor native species. But know that, you know, depending on how changed your environment is, sometimes the non-native species may be a little bit better in your setting. So here are some resources. We will probably make this PDF available to everybody, so you don't need to scramble to write these down. But these are excellent sources of information on all types of pollinators. And I guess I really don't need to go into all of these. The first five are books, xersesociety.org. They have a website. And then if you need a source for what we call straight species, non-hybridized species, Prairie Moon Nursery in Minnesota is a good place, and Ernst Seeds out of Pennsylvania is also a good place. I've bought from both of them and have had very good luck. So I think that concludes my portion.
Thank you, Sue. That was wonderful. This is Heidi again. I have a couple of questions. If anybody else has questions, feel free to raise your hand or type it in the chat box and I will ask them to Sue. So one of the questions is about chokeberry.
I can't hear you, Megan. About what kind of berry?
Chokeberry?
Soapberry? Okay.
No, sorry, chokeberry.
Oh, chokeberry. Okay.
Is there different kinds?
Pardon me?
Is there different kinds?
There's black chokeberry and there's red chokeberry. Two different species. The genus is Aronia. Both of them have edible berries. The black is preferred because it has those dark berries, which are very healthful, have lots of anthocyanins in them and considered to be a tonic, anti-cancer agents, things like that. So the black chokeberry is probably going to be the more desirable species.
Great. And then can you describe burning bush again and how you would know if you have burning bush?
Okay, well, if you have a small shrub in your yard, you know, depending on whether you prune it or not, it can get up to 15 feet tall, but it's a very stiff shrub. It has fiery red foliage in the fall. And if you look at the twigs, more than likely the variety that you have is what's called winged euonymus. And the twigs will have little appendages that come out on four sides. So it's almost, I guess, well, it's like wings on the twig. And that's probably the best way to know that you have burning bush.
Okay, and I have just a general question. If someone called you up and said, I have a sunny spot in my yard and I want to plant 3 fantastic pollinators, what would your top 3 be that you would recommend?
Okay, unfortunately, it's not that simple because we have to take into account what your soils are like, whether it's a clay soil, sandy soil, is it well drained? Is it a wet soil? How much sun does the site get? Is it shady? Is it sunny? So, you know, in that situation, I would, you know, depending on, you know, if you had ideal conditions, I would go with, you know, for 3 species, I'd go with, you know, one of our native deciduous trees, which is an excellent food plant. Maybe go with some of the dogwoods as a shrub. Sumac is a good shrubby species, although a lot of people don't like it because it does sucker, but if it's in a lawn and you're mowing, that's not going to be an issue. And then just some of the native wildflowers. So just a small grouping, something like that.
Thanks, Sue. And I mentioned earlier about your hotline.
Yes. And before I give that, I think Diane Peebles, I think she was trying to physically raise her hand. You got to unmute yourself, Diane.
I might have to unmute her. Unmute. Hi, Diane.
Hi, can you hear me?
Yep.
Okay. Sue, do you remember over to the old ACS building? Are those burning bushes? Remember all those red leaf hedge? Is that a,
That's probably what it is. That's kind of the typical setting that you would see. I mean, I don't remember, but it wouldn't surprise me if in that setting that would, you know, probably just would have been their go-to species to plant.
okay, because it was continually red. Okay,
Well, burning bush is not continually red. It's only red in the fall.
right.
So
Okay,
I'd
thanks.
have to see it.
Does anyone else have any other questions for Sue? Let's see.
There's a lady that,
Looks like Vicky's raising her hand.
Okay, I'm not seeing that, but let me,
Vicky, do you need to be unmuted? There you go. Oh, it's not working for me.
let me try. Hold on. Didn't get to her name.
That's weird.
All right, I will unmute me.
Go ahead, Vicky.
Can you hear me?
Yes.
Yay. I just have a quick comment. What we have found, we have about 1.5 acres and we're on the Indian River. And what we do is we mow a lawn around the house minimally, and behind the house, we mow once a year. And we have a pocket wetland, and we also have, we just let things volunteer. And if you know the leaves of plants, you know what they're going to be, and we leave them. And so we've ended up with smaller forget-me-nots. We've ended up with fringe loosestrife. We have Joe Pye weed. We have ironweed, and about 25 species of trees. And it's easier than maintaining a lawn, and you get a lot of pollinators.
Good luck with that.
Yeah, that's a good point, Vicky. If you just leave it to Mother Nature, she usually will
Yeah.
straighten things around. But again, you know, in that situation, I know you guys are familiar with invasives. You know what you're looking for. But if you're going to do that, you need to become familiar with invasives, so those don't move in. And the big ones that would move into a setting like that would be buckthorn and honeysuckle.
And we have a few honeysuckle, but rather than try to remove them, what we do is we don't let them flower.
Yeah.
But the one we do have is goutweed, which you call bishop's weed.
Yeah. Yep.
And it's not as bad as Japanese knotweed, which we've battled for 30 years. But I will say that goutweed does attract a lot of pollinators.
Yeah, it does, but
You just have to keep it under control.
it's just so invasive that I just don't want to encourage anybody to.
Oh, don't plant it.
Yeah.
Never plant it.
So if anybody has further questions, you can call me on our horticulture hotline. It's 315-405-0982. That is a number we're using during the COVID-19 crisis. Hopefully in another couple weeks, we'll be back at our office. And that line is operational from 9 a.m. to 3 p.m. Yeah. Okay, Heidi, take it over. I know Matt is waiting and I'm anxious to see his presentation also.
Yeah, me too. So thank you, Sue. Next we have Matt Schlesinger. Matt is the chief zoologist with the New York Natural Heritage Program. And Matt's presentation is mainly focused on really neat community science projects that you can be part of to help our pollinators. So go ahead, Matt.
Thank you, Heidi. Can everyone hear me okay and see my screen?
Yes. Yes.
I think I'm hearing some yeses. So that's great. Why don't we have everybody else mute if you could, or Heidi, if you can mute everybody, and I can always unmute myself after that, just to reduce the background noise. Okay, that seemed to work. thank you very much. And we can have questions as we go, post them in the chat, or if you are desperate to ask a question and need to unmute yourself and ask it, you can do that too. So as Heidi said, I'm with the New York Natural Heritage Program, and I'd like to acknowledge my co-conspirator in this project, Erin White, who is her training is mainly in invertebrate zoology and ecology and conservation, and she works on a variety of projects with our program too. So she and I are co-leading this effort. She's the official project coordinator, and we sort of share the duties of presenting the work in various forums. In previous years, we've been able to do live workshops, and this year we're doing a few remote trainings and things, and then pointing people to a more involved training that I gave to the Central Pine Barrens Commission from Long Island, and I can share that with you in a follow-up. I think we're preparing a follow-up email for all participants, and I'll share a link to that presentation. So if you're interested, if this piques your interest and you want to learn more and think about participating in the project yourself, then you'll have resources to do that. So the project website also is very easy to find. It's a no-frills website, but it's a place where we can post information. It's there at the bottom, mynhp.org/pollinators. Again, you'll have that later. No need to scribble it down. I should be able to make a PDF of this presentation and share it with everybody as well. A little introduction to our program. I'm hoping that the slides will change. Good. The New York Natural Heritage Program, just for those of you who might not be familiar, every state and most Canadian provinces and several Latin and Central and South American countries, have a natural heritage program. These were created starting in the 1970s by the Nature Conservancy, and then spun off to various state agencies and universities and some independent nonprofits. They're coordinated, and sort of the umbrella organization for them is NatureServe, who a lot of scientists from the Nature Conservancy were interested in biological inventory, spun off and formed that group back in the late 90s. And we now, after many years with TNC, are a program of the SUNY College of Environmental Science and Forestry. So we are housed administratively within SUNY ESF, and we have a lot of partnerships with faculty and students there, but physically, or geographically rather, we're in Albany, New York, and we're housed in the state office of the Department of Environmental Conservation in downtown Albany, at least when we're allowed to go to the office. Right now, we're housed, as many of you are, in our homes, working as best as we can through the current pandemic. So, that's the Natural Heritage Program in a nutshell. This slide I often use as a disclaimer for saying I'm not an entomologist by training. I'm actually I have a master's and PhD that were both on birds, avian ecology and behavior, and then since I've diversified my portfolio and I work on a variety of animal types. I have certain specialties and interests like leopard frogs and tiger beetles, and I'm interested in all things, but I help coordinate. I have staff who coordinate a whale monitoring program off of Long Island, and everything down to beetles and bees. And so you can see I'm spread pretty thin, and I use that as a disclaimer for I might not be able to answer your most complicated insect questions, but I'll do my best, and I'll be honest about what I don't know. I usually have a different picture in the lower right corner, but then I noted that Julie Hart, who is on my staff as the Breeding Bird Atlas project coordinator, is presenting the next of these IRLC webinars tomorrow evening. And so I encourage you to listen to her. She gives a good presentation all about atlasing, bird atlasing, and why it's so important and how you can get involved. Another great citizen science effort that we're really proud to be coordinating. So so that's enough advertising, I think. We're here, because pollinators are known to be in decline, and some of this will repeat some of the information that Sue gave you, but since my name is apparently also Sue, I feel like that's okay. You can see in newspaper headlines, but also in the scientific literature, that there are a lot of pollinators in decline, and these are examples of scientific papers, because that's my medium, that have documented pollinator declines over the years. I'm not going to read them out, But in the last, 10, 20 years or so, since that book, The Forgotten Pollinators, came out about 25 years ago, and it took a while to get into the public consciousness. But then with colony collapse disorder hitting honeybee populations, people started also paying attention to our native pollinators more. And what are the causes of those declines? Again, Sue's gone over some of this. This is my version of some of the same information, but invasive species like Japanese knotweed that Vicki just mentioned, and the fly there is an invasive Compsoglypha that was introduced to this country to control gypsy moths, but actually has impact on a lot of native moths, and including pollinating moths like hawk moths, or also called sphinx moths. Pesticides we've talked about. Habitat loss is certainly a key factor, especially developments that are named after the habitat types that they've destroyed. I don't know if, honestly, those are any more of an impact than any others, but interruption of natural disturbance I put on there as an example of, this is particularly true in pine barrens ecosystems where the suppression of fire, which these ecosystems have evolved with, has led to pine barrens being kind of choked with vegetation. And so there's not an opportunity for the bare soil to be created and exposed in the way that a lot of bees and other organisms need. And then climate change, of course, we're still figuring out the impacts of climate change, but there has been some literature on this. And one example that this graph is intended to show is the mismatch that's possible when flowers and their pollinators have co-evolved for thousands of years, and then climate change causes one of those to be delayed or accelerated, but not the other. And so there's the potential that a pollinator will emerge and it has nothing to pollinate because perhaps the blooming time of that plant has fallen behind, or vice versa. So these sort of concerns led to action at the federal level. There was a pollinator task force that President Obama charged with developing federal priorities, and that trickled down to the state level, not necessarily with money, but with a directive to develop a pollinator protection plan. And New York State did that in 2016. They came out with the New York State Pollinator Protection Plan, and in it was the paragraph that you see there is, DEC will begin a multi-year evaluation of New York's myriad native pollinator species to show the current status and distribution of native pollinators, and serve as the foundation for developing and implementing conservation practices. So that was the charge that was put in the pollinator plan. Around the same time, or a little bit before that, actually, the New York State Wildlife Action Plan was released. This is a document that the state has to put out in order to receive a certain kind of federal funding called state wildlife grants funding. And my program nominated bumblebees as consideration of some of the species that they were concerned about, what they call species of greatest conservation need. And there was a ranking system, and bumblebees rose right to the top, several of our native imperiled species of bumblebees. So 2 examples of those getting into the state's consciousness and the public consciousness. And the DEC chose to fund us to develop and implement this native pollinator survey. So we started doing that in 2017. And actually 2016 is when we first started gathering people. We recognized at the time that we are, as a natural heritage program, we dabble in a lot of things, but we're not experts in everything. And so we brought together a fantastic advisory committee and that's no pat on my back, that's just honoring the expertise of the people that we got to help us, which included some national and global experts on pollinators. So we grabbed all these people together by phone and then in person and designed the project that I'm going to describe to you next. And so I thank them for all their help. We came up first with a goal statement, and just to make sure that we were all on the same page of what we were trying to achieve with a native pollinator survey, because the direction from the state was rather broad and vague. They said, survey pollinators. And we said, ooh, okay, what pollinators? And how should we survey them? And where? And over what time frame? And so we said, okay, first, we're going to determine the conservation status of a wide array of native insect pollinators in non-agricultural habitats. And the key words in there, I think, are native, right? So we're not talking about honeybees, for instance. We're not interested necessarily in their status and conservation. There's agricultural groups that can handle them. Non-agricultural was important because we wanted to focus primarily on natural native ecosystems. And conservation status, I know I'm jumping around there, but conservation status, what we mean by that is it's a very specific thing for natural heritage programs. We calculate what we call S ranks, and that's for status rank. Actually, S stands for subnational because there are G ranks for the global populations of species, and NatureServe maintains those. They range from 1 through 5, and they give an indication of the conservation status of species. So the 1 through 5 indicate imperiled all the way down to secure and things in between. And for most of these native pollinators, we didn't have S ranks. We didn't have an idea of their conservation status. And so that was a primary goal of our project. We are now we're no longer in April 2020. I should update that slide. We're now in May 2020. We have this final field season, unless the pandemic ends up prohibiting us from doing all the field work we intend to do this year. At the moment, it seems like we'll be able to proceed. So a final field season, and then just over a year to analyze the data and finish the specimen ID and analyze the data and write it up and deliver the final product by 2021. So it's the final year of the project and a great time for people to get involved. We, as I mentioned, wanted to cover a wide array of native insect pollinators, and so we chose focal groups from the major orders of pollinating insects. And these are all for you Latin fans within the kingdom Animalia, phylum Arthropoda, class Insecta, and then these are different orders: Hymenoptera, the bees, wasps, and ants; Diptera, the flies; Lepidoptera, the moths and butterflies; and Coleoptera, the beetles. I'm going to give a few more slides of introductions to some of these groups. A lot of these slides were taken from and adapted from workshop materials that Erin, my co-coordinator, originally developed, and I've adapted them for different purposes. And some of them are, more teaching slides, and so they have a lot of text on them, and some of them are just pretty pictures. So the format will change as we go, just based on a whim more than anything. So let's talk about bees. These are things that Sue also touched on, and but I can reiterate. I always like hearing things more than once. They sink in a little bit better. So bees are, they're fuzzy often, they're hairy, they have eyes on the side of their head, and that's an important character for distinguishing them from flies, as is the number of wings. So Hymenoptera, everything in that insect order has 4 wings. Bees and wasps have 4 wings. Diptera, that's Diptera, the 2 wings. And so if you can count the number of wings, which you can't always do, you can tell pretty quickly whether it's a fly or a bee. And I'll show you some more pictures that demonstrate that too. Females are out foraging and carrying pollen, and this is a handy little number to have in your toolkit. 416 species of bees known from New York State. That's a number compiled by our colleague at Cornell, Brian Danforth, who's the world's expert on bee ecology and conservation. And as Sue also pointed out, there's some bee mimics out there, and somebody mentioned in the chat this would be a good name for a band, and I totally agree. In fact, I'm gonna go form one after this talk is over. Our music is all the buzz. Sorry, I said I wasn't gonna make a buzz joke. I promised I would not make a buzz joke. Some bee mimics include the syrphid or hover or flower flies, like on the upper left. That's a wasp at the lower right, and I'll show some characteristics here. So I think you'll be able to see my arrow dancing around here. Look at the eyes of this fly and how big and forward facing they are. Sometimes with males, they even touch in the center, as opposed to the eyes of the Hymenoptera. These are wasp eyes, and they're more on the side. Flies also have just the 2 wings, right? Again, sometimes 4 wings can look like 2, and so you have to be careful with that one, but that's key. The other one you can't see very well here with flies is that they have usually very short antenna versus bee antenna, Hymenoptera antenna that are quite a bit longer. A wasp is usually less hairy than a bee, has this typical wasp waist, very narrow constriction. However, there are bees that have that too. So it's not a perfect characteristic. Wasps are typically less hairy as well. And then I had a bee expert tell me once, wasps look militaristic. And I don't really know what that means. So you can use that if it's helpful to you. When you look at them head on, it does look like they want to kill you. And so maybe that's what she meant by that. This is a bee fly on the lower left. Bee flies, again, they're flies, right? 2 wings, big eyes facing mostly forward. Bee flies have this very long proboscis that they use for pollinating, and I'll talk about them in a little bit more detail in a minute. And this is a bumblebee flower beetle, also called a bumble flower beetle. I saw my very first one like 2 weeks ago, and it was flying across the ground. And so this is a bee that, or excuse me, a beetle that mimics bees in their behavior more than in their look. So yeah, they're fuzzy, but they don't really look like a bee otherwise. But they fly in a way I've never seen a beetle fly, all around, sinuously across the ground and buzzing. And so I swore it was a bumblebee at first, and then I thought it was a bee fly that buzzed for some reason. And then when I caught it is when I knew that it was actually a beetle. A pretty neat insect, and really good pollinators too.
And we photographed them about a week ago.
You did?
Yes.
Yeah,
Yes.
and they look and sound like bumblebees initially.
Yeah.
Until you get down close and start looking.
Well, plug for IRLC, we were by the gazebo on the Redwood Preserve,
Yes.
Redwood Hills
Hill.
Preserve, and I was sitting there minding my own business, and I couldn't figure out, Matt, what the heck this thing was flying around. It looked like a flying, I don't know, I'd never seen anything like it, and it took forever to capture one.
Yep.
Yeah.
That was my experience too. Yep.
It was totally amazing, which I think is the most fun part of all of this, is that the things are just outstandingly sensational when you start looking at these critters that are saving the world and providing our food for us and everything. It's pretty cool.
Pollinators are neat.
They're endlessly fascinating, aren't they?
Yes.
I agree.
Yes.
So,
Okay, Mutiny.
okay. A little more on bee. Thank you, Steve and Vicki. Steve and Vicki have been volunteers with our program and been working with our program for a long time, ever since we had a statewide dragonfly and damselfly atlas. They were huge contributors to that. And so it's nice to connect. I haven't gotten to see you guys for a long time. So bees have a variety of nesting behavior. Some of this you will know. Eusocial bees, the ones that are truly social, that means that they have a queen, they have workers, they have drones. Honeybees and bumblebees fall into that category. Then there are semi-social bees that use the same nest but don't exist in this sort of collaborative way where it's all for the good of the hive and really to pass on the queen bee's genes. There are communal bees that are technically solitary bees, but they'll use the same nest hole entrance. And then there are aggregations where solitary bees build nests that are nearby one another. I'll show you a picture of that in a minute. Finally, there are just solitary bees that females build and maintain their own nests, and they're totally independent of other bees. So a wide range of nesting behavior in bees, and a wide range of places that bees build those nests. So here's an example of an aggregation of solitary nests, right? So again, loose soil is so critical for bee nesting, but also some bees nest in tree trunks and dead wood and even twigs. So a little bit now on a few different groups of bees, and then we'll go into some other taxa and then talk about the citizen science effort. In New York, we like to talk about bumblebees because they're adorable and important pollinators and in serious decline. So we have 14 extant species in New York, and that's extant meaning still existing, because I think there are 4 that are historical from New York, meaning no longer found, no longer can be found. We were hoping we'd find some of those with our effort, and there's 1 species that's popped up in recent years that we are documenting through the survey. But one of the historical or possibly extirpated species is the rusty-patched bumblebee, which you might know as the only federally listed species of bee. New York isn't considered part of its range by the Fish and Wildlife Service only because it has not been seen here in over 20 years. I think 1999 was the last occurrence. Sorry? Bumblebees are eusocial, and they're generalists, as Sue said. So they forage on many plants, and they buzz pollinate, as Sue talked about. And not that I wasn't paying rapt attention, but while she was talking, I also found, I think I have to stop sharing new share, I can say. Found this video of buzz pollination. Everyone seeing that okay?
That's what they do.
So they buzz to release the pollen from the anther. All right. Now let's see if I can go back and get this back on. Okay, so that's fun. Oh, looks like we started over again. So that's all right, I can go back. Give me a second here. All right, we should be back at the PowerPoint. Everyone's swatting at their faces now, the buzzing sound. So bumblebee's life cycle is really interesting, and it's worth a quick mention. When you see a bumblebee in April and it looks particularly large, that's because it's a queen bee. Almost anything you see in the month of April and often into early May is a queen bumblebee that has emerged from hibernation and is looking for a place to nest. Then she disappears for a little while. She might be foraging at that time, or she might be looking for a nesting site. And not all queens make it. You know, not all successfully build a new nest. They might build someplace that gets disturbed, or they might get, you know, they might get preyed upon. But that's her goal in April. And then she lays eggs. She has drones and workers, and the drones help maintain the nest and then become mates. And the workers go out and find pollen to feed the young. And that happens off and on into the late summer, early fall. And then the queen and the drones mate and fly off to find a place to hibernate. And then everybody dies except the queen. So every bumblebee in the world is dead except for queen bees in the wintertime. And the queens then emerge again in the spring. And it starts over again. Another neat group in this family of bees, it's the Apidae is the family, are the longhorned bees, so-called because they have longer antennae than a lot of bees. They're ground nesting, solitary, and the males are communal sleepers at night, which I've never seen but sounds adorable. And many of them are sunflower specialists. So late summer is a good time to look for these guys on asters and you know, sunflowers and things like that. The mining bees are part of the largest family in New York, 86 species of mining bees. And they're called mining bees because they are ground nesters. So these are two genera, Calliops and Andrena, and these are really hard to tell apart even for experts. So our colleagues at Cornell who are doing the most of the bee identification for our project are looking to DNA barcoding to help tell these Andrena species apart. Leafcutter bees are just like you might think. They cut leaves and they line their nests with little bits of leaf. And they have big sharp mandibles to help them do that. They can nest in a variety of substrates as well. And as much as I want this to be pronounced megachile, it's not, it's a megachile, and it's the family Megachileidae. Another group the other thing about the megachilids is that they often collect pollen on their abdomen. So you can see how fuzzy that is. So if you see a bee that has a lot of pollen collected on its abdomen, as opposed to pollen baskets like bumblebees and honeybees have on the legs, they have these pollen baskets that collect pollen. If you see some on the underside of a bee, it's probably a megachilid. Another one are the mason bees, same family, and called mason bees because they use mud to build partitions between their cells in the nests. And this is the other group of managed bees that are actually native, are mason bees. So sometimes these are managed as pollinators that can be brought to farms and released, and seems like a better way to go to me than honeybees. Oil bees are every bee specialist's favorite group of bees because they're all rare. And these are ones that collect the oils from flowers and feed on the oils from flowers rather than pollen or nectar. In particular, there's Melita, which is a specialist on vacciniums, and Macropus, which is a specialist on native loosestrifes. So not purple loosestrife, but the native loosestrifes in the genus Lysimachia. So if you are finding Lysimachia in bloom and you see a tiny bee that's pollinating those, that could be a Macropus, and there's just a handful of records for those for all. There's 3 different species, but they're quite rare, just a handful of records in New York. We're not focusing on the sweat bees because their taxonomy isn't entirely stable and they're incredibly hard to tell apart. And but I thought I'd mention them because people are familiar with them. They're bright, many of them are bright metallic green or metallic green with a beautifully striped abdomen. And so a lot of the small and attracted to human sweat, which is why they're called that. So you'll see those around and certainly worth photographing and contributing to the project, but won't be something that we're able to spend much time analyzing data on or even identifying because they're so hard. A little bit more about honeybees. So for their identification, some key characters are the shape, that's sort of a torpedo shape with a striped abdomen that's orangey brown or often can be very dark. Again, they have pollen baskets. I'll try to bring my arrow back and show you. This is a pollen basket, a scopa it's called. And then the key characteristic is the cell of the wing. So good luck finding that. But if you happen to get a really good view of a honeybee and can see the cell on the wing, the marginal cell is long and curved. So it's like a long sausage instead of a short hot dog. And I put a quote in here from a recent paper. There's a lot of evidence coming out that high density of non-native honeybees is in fact causing or very likely responsible for declines in some native bees. I've seen this anecdotally. I've been to places that I think should be full of native pollinators and it's all honeybees. And then it's pretty clear that there's a pretty high density beekeeping operation in the area. And those bees are coming out and probably outcompeting with and possibly passing disease on to native pollinators. All right, we're gonna move past bees into hoverflies, which Sue also touched on. A lot of these are bee mimics, as you can see. Remember that all of them have these big forward-facing eyes, 2 wings, and typically very short antennae. You can see the short antenna, especially on this guy at the bottom middle, and this wood fly. This is a really rare species here on the lower right. So the syrphids, or also called hoverflies, also called flower flies, are usually considered kind of second only to bees in terms of their pollination importance for native plants. And they're super cool group. And they're hoverflies because of their flight patterns. They will hover and you can start to tell the more time you spend looking at them, you can see a bug that you would have just dismissed as a gnat or something and realize there's actually a hoverfly and it's doing a really important pollination service. I'm sure gnats also are important for something besides just feeding bats, but I'm not sure what other ecological roles they might have. But so hoverflies are really cool, really diverse, 300 odd species in New York. We're focused on a particular group of them that are old growth forest dependent. So as larvae, they require rotting trees, downed logs, snags, and then as adults, they're pollinators. The bee flies, I love this group of flies. I don't really know that I knew it existed before that. As I said, I'm not an entomologist, but I didn't know that I knew they existed before starting this project. But they're super cool. And if you didn't expect to hear the phrase cutest fly during this presentation? Well, I'm about to say it. Is this the cutest fly you've ever seen or not? On the lower right, look at the tiny little teddy bears. They look fake to me, but they're just so adorable. Key characteristics of bee flies are these really long proboscis, and then the wings are swept back like a fighter jet, right? So the shape and direction of the wings is pretty key, and then they're super fuzzy, of course. This is a really rare one that somebody found on Staten Island this year. It's called the pygmy bee fly, and it's just gorgeous. Beautiful, beautiful insects. And excuse me, they're actually parasitoids on some native bees. So they lay their eggs in other bees' nests and are parasitoids that way. But then the adults are pollinators. So they're an interesting one because they might seem to have negative impacts on some native bees, but probably not enough to be concerned about. But then they are pollinators as adults. And we're focused on this one genus of bee flies in the family called Bombylius. Beetles, I've gotten really into different kinds of beetles over the years, and this is the group that we chose to focus on in our project, the flower longhorn beetles. So we're in the longhorn beetle family, which is Cerambycidae, and then the flower longhorns are the leptorines. And there's about 100 species in New York, including the very large, you can't see it from this picture, but it's an elderberry longhorn, and it's probably, a body itself is about an inch long, maybe even a little bit longer than an inch, plus the antenna. So, you know, good sized beetle there. And then these are some other examples of beetles in this subfamily. I've also stuck on here, one of the other focal groups is this small genus called Trichiotinus of hairy flower scarabs. And so these are scarab beetles or dung beetles that are pollinators. And it's a group that, again, you know, these are all species groups that we knew very little about, but suspected that there could be conservation concerns given what's happening with some other native pollinators. Into Lepidoptera, just a quick review of, you know, is it a moth or is it a butterfly? There's some generalizations on here that I don't love, but butterflies are active during the day, whereas moths are active at night. Well, that's generally true, but there are a lot of day-flying moths too, including some pollinators like the hummingbird clearwing moth, the Nessus sphinx, and some other day-flying moths. So butterflies have clubbed antenna, and moths typically have feather-like antenna. I'm trying to get my arrow back; it's hard to get. So a little club on the end of the antenna. You can see it here on this fritillary. You can see that club on the antenna. So that'll tell you if you're not sure if it's a moth or a butterfly. And then the position of the wings at rest is pretty important. So there's butterflies will fold their wings over their backs, whereas moths connect them with a little fringe, and it actually explains their erratic flight to some degree. Here it says butterflies are usually more vividly colored than moths. Maybe that's usually true on average, but there's some very strikingly colored moths. If you've ever seen a rosy maple moth, for instance, any of the giant silk moths, for instance, are super, super beautifully colored. So our group, we in our project, we're not really covering butterflies at all, even though they're appealing to people and they're very attractive, and we're getting a lot of photographs submitted of them in our iNaturalist project, which I'll talk about in a minute. But we actually understand the conservation status. We know something about the rarity and degree of impairment of a lot of butterflies, but we know much less about many of the moths that are pollinators. So these are the groups we focused on: the sphinx moths, family Sphingidae, and in all frankness, there are some sphingids that do not feed as adults at all. So they're not all pollinators, but many of them are. About 25 out of the 45-ish, those are approximate numbers, species of sphinx moths are pollinators as adults. This is one that I particularly like to talk about. It's the tomato hornworm that is the bane of every tomato grower's existence as a larva, right? So it's naughty as an adolescent, but when it grows up, it's a sphinx moth and it's a pollinator. So there's another sort of paradox, a most ingenious paradox that that sphinx moths as babies are pesky, but then as adults are ecologically pretty important. Some other moth pollinators, the other group that we're paying attention to are these little guys called Shinia moths, or flower moths they're called. This isn't primrose, evening primrose? No, primrose moth, it's just called. That's another Shinia. And then you'll see other moths pollinating, especially during the day. My dream project is to learn how to photograph them at night. And occasionally I can see pictures and video of people who've captured pollinators pollinating at night, and it's just super cool.
Mhm.
We're taking 3 complementary survey approaches in our work, and one of them is surveys by professional biologists, including those on our staff. We use bee bowls to trap pollinators and then nets to collect them. We do a lot of specimen collection, and that's not for everybody. We knew that wouldn't be for everybody, and that's one of the reasons we wanted to have a community science effort that was focused not just on specimen collection, but also on photography. So here's Erin White training people in one of the workshops, and there she is giving the presentation portion of the workshop. We do encourage people to collect specimens, and I'll go into why in a minute. Well, actually, no, I think I killed that slide, so to save time. But a lot of species cannot be identified without a specimen in hand or under a microscope. And so it was pretty important that we be able to collect specimens. We also know from the literature that collecting specimens has very little, if any impact at all on the local population. And then we can use those specimens to become museum records that can be used in the future by others. So it's not something that everybody wants to be part of, and we understand that. And that's why we have such a big photography component of our project. We use previously collected specimens all the time when we go to museums and try to reconstruct the historical distributions of a lot of these species. So I'll talk mostly about the iNaturalist portion, but we do have a participant handbook that's online at that website I pointed out to you, and it goes through the process for if you're going to be collecting specimens, what are the data to record, and some of the methods. We have links to videos and things you can watch on the different collection methods. And then I wanted to recommend a few books. These are some of my favorite field guides and non-field guides. One of the better guides that I've seen that covers all the bee groups is this one called The Bees in Your Backyard. Again, you'll get a copy of this presentation, so you don't have to scribble everything down. The recent bumblebee guide that came out, I think this is 2014, very thorough, very great, a little intimidating though, in terms of the number of different possible patterns they show you for all the different bees. They're trying to cover their bases on all the different possibilities, but it ends up making it, for me, a little hard to be sure of what I'm looking at. Maybe that's the bees that are making it hard to be sure of what you're looking at, not the book. But you're living in a wonderful time when a field guide to the flower flies of northeastern North America, hoverflies, flower flies, is available. It came out just last year, and it's fantastic. And so I highly recommend that book. And then there's natural history books on hoverflies too that are interesting if you want to learn a bit more. Here's some of the ones on beetles and moths and butterflies that I like. This Beetles of Eastern North America is great. It's a big book. You're not going to take it in the field, but it covers a little bit of everything. Some of the most common beetles in all kinds of beetle families. It can't cover everything because there are more beetles in the world than there are pages, but it does a great job of showing you the most common things. Here's a guide to longhorn beetles, recent field guide to moths, the Peterson guide that I like. And if you live up north, as many of you do, I suspect, this series of the North Woods, there's the rosy maple moth. Mm-hmm. These moths and caterpillars and butterflies of the North Woods book, and there's a dragonfly and damselfly one too, if you're interested. These are great. I love this little series. And then a couple others. This is one that Sue mentioned, the caterpillars. This caterpillar book is fantastic. David Wagner from University of Connecticut is a god. And I can't get through without plugging the work of some colleagues. So Brian Danforth from Cornell just put out this book on the biology, evolution, and conservation of solitary bees. So he's focused on the roughly 2/3 of New York's bees that are not just New York, but of bees that are not social. And then these fantastic portraits that Sam Droege from the United States Geological Survey, based in Maryland, has been doing for years now. And some of them have shown up on various posters and advertising campaigns and things. And he's got a book of them too that he doesn't make any money off of because it's all federal government. So if you want to give back to the poor federal government, you can buy that book. But a lot of his photos are free and available online too. Okay, and some online resources for identification and natural history. These are becoming, far and away the best sources of information because there are so many experts out there who can share their expertise helping you identify things. And so these are some that Bug Guide is one of those, and you can post an image and say, what's this? I don't know what it is. And somebody can help you figure it out. And iNaturalist is the same way. We'll talk about that in a minute. Here are some other specialized ones for butterflies and moths and leps. Discover Life has great keys for bees and some other insects. So, and the keys are not the kind of dichotomous key that you might know about where you have to, is it this or this? And if it's this, you go to page 12, and if it's that, you go to page 17. These are called random access keys, which means you click on and you select all the features you know about, and then it narrows down the universe of possibilities for you. And so they're really handy. And then our own guides, conservation guides that we put out for rare species, and those are online at guides.nyNHP.org. You can learn about the ecology and conservation, habitat, and distribution of a lot of the rare species. We're still building those for pollinators, but we have maybe 10 to 12 of them for bees and flies so far. Another couple things, classic bee online keys, a great paper on bee flies. These are open access, which is great. So this really nice paper on bee flies is sort of the best field guide we have. And then Surfit's also a key to Surfit's. And you'll have these links later. All right, so now is when I was gonna go do the iNaturalist demo, but I wanna stop and breathe and have a sip of water and see if people have any questions.
I have a question in the chat.
Yeah, speak up if you could, Heidi.
The question is about Japanese beetles, and is it okay to use trap?
Japanese beetles and
trap for trapping them.
and trapping. What specifically
Just they're coming from somewhere.
about trapping?
This is Sue. Can I help out with that? Are you talking about the Japanese beetle traps that people put in their yards?
Yes. Yeah.
Yeah.
I'm not familiar with them. Go ahead, please.
Okay. They do catch Japanese beetles. In fact, they will catch a lot of Japanese beetles, but we don't recommend them at Cooperative Extension because basically what they do is they draw more beetles to your yard. It seems like you're doing a really great job in eliminating them, but you're just drawing more in, and we tell people if you're going to use them, put them in your neighbor's yard.
You want to raise your hand?
Yeah.
Steve, do you have a question?
Yes.
Go ahead.
Can you hear me?
Yes.
Okay. Well, just 3 points. Matt, use a headlamp. Go out at night with a headlamp, and you can see the eyes of moths and butterflies, and a lot of spiders too. But it's really easy to find them that way at night.
Yeah, great suggestion. I've tried it. I haven't succeeded yet, but I'm only able to get out a couple nights a week when I'm not putting kids to bed or something.
Okay.
But yeah, great suggestion.
And I was thinking too about the fact that bumblebees, can generate heat in order to stay viable. But this spring has been ungodly cold, and what I noticed was honeybees were out and about, and there were no other pollinators to be found. So I don't know what the deal is with the honeybees versus them, but that could be some kind of biological edge that they've got for really cold weather. And the last thing, and we'll be quiet, we used to trade asparagus for the apiary across the street from us, run by Buster. And I went over one day with a bunch of asparagus, and he had his head net on, and I said, Buster, you got a bunch of bees inside of your net. He says, that's okay, Steve. I put them in there to keep my face cool during the day.
This was a person who could he usually didn't put anything on to do his hives at all. He could just handle the bees with no problem. What I was going to, I have some seeds for fringed loosestrife, if anybody is interested. And Heidi, if somebody wants to contact you, they just showed up a few years ago in our yard and we let them grow to see what they were exactly. And so we do have oil bees now because we have fringed loosestrife.
Wow. Nice.
And we also we found that between the lamb's ear and moth mullein, we have wool carding bees, which live right next to the plants in the ground. And we have leaf cutter bees.
Fantastic.
Just have to watch and see where these things go sometimes. So, yeah. Sorry, we spend too much time watching things.
No such thing. Too much time.
Oh, yes, we do.
Vicki, I want to mention that I would love the tomatoes.
I've just started the seeds for them, for the grape tomato. It's a family tomato for Megan. Okay.
All right. Any other questions before we dive into iNaturalist? Well, then you should be seeing my phone screen now, and it's narrower. That's how you'll know. Let me know if you don't, but it seems like it's working. In fact, because I've shared my phone screen and I see it on my laptop, so I know it's working. That's good. And what I've done is opened the iNaturalist app on my phone. I'm not going to go through the details of downloading the app and setting up a profile, but I want to show you just once you've done those initial steps, how, a little bit of orientation to it, and then how quick it is to upload an observation and contribute to our project or other projects that you might be interested in. So what I've done is open the screen that just says, when you tap on the lines at the upper left, this is my set of my observations. I have 294, which is not that impressive compared to a lot of people, but most of them are pollinators. But if I just want to explore generally what's in my area, I tap on that explore. And it shows me observations of all the things that have been submitted to iNaturalist that are in this area. And I don't know precisely how it determines what area it's looking at right now, but you can then specify the area if you want. And I'm going to scroll through a little bit to show you people are posting plants, people are posting animals and snakes and a shrew, it looks like, which is cool, and birds. And so all kinds of things are getting posted to iNaturalist. And then within iNaturalist, you can build a project to collect observations of a certain that meet your criteria. And so we've done that with the Empire State Native Pollinator Survey. And I'll go to projects here. And I have a few projects I've joined and participated in. And the third one down is the one that I built, and it's called the Empire State Native Pollinator Survey. And so this is the kind of homepage of the Empire State Native Pollinator Survey. And over the 2+ years of the project so far, we've gotten 11,000 plus observations of pollinators. We restrict it to those 4 major insect orders and that it has to be in the state of New York, and it has to have a photograph, and it has to have coordinates with it. So that's those are our criteria for being able to submit to this project. And you'll see that people have posted all kinds of bees, butterflies, as I mentioned, even though those aren't a focus, it's fine that people are posting them there, and because I can always filter those data out later. And so again, I'll scroll a bit, and one thing to point out is this RG label you'll see at the in 2 of the records at the top row. That's what iNaturalist calls research grade. And a research grade observation is one whose identification is agreed upon by more than one person, by 2 people or more, and that has precise coordinates to it so that it can be used in research is the idea. It is not foolproof. I have seen research grade observations that turn out to be wrong because 2 people agree, but they're wrong. And that's, that's sort of the nature of any kind of science really, but citizen science projects that where there are people jumping on and saying, yes, that's what it looks like, that's what it looks like. And in fact, it might or might not be that. And you can only tell from a specimen in hand under a microscope and so forth. So there are errors, but it's been a really valuable source of data for us for the project, and I really love it. So just a quick scroll through here just to show you some of the other things that have been posted. So there's some syrphid flies, lots of bumblebees, and many of these, and with, you know, if they were posted recently, they might not have attained research grade yet, but there are bee experts on iNaturalist who will go in and help us identify these. And so we rely a lot on this community of experts to do the identification for us. So you can see if in any given one of these, I'll open up the common eastern bumblebee record there. And you can see this person posted a couple of photographs, which is great. More angles is really good especially for bees to be able to make sure we get the important features. Often the face is really important for bumblebees. And then I'll click on this little chat looking thing in the middle. And you can see that the observer said, I think it's a common eastern bumblebee, Bombus impatiens. Somebody else agreed, said, yes, I agree, it's a common eastern bumblebee. And because they agreed and it's got coordinates, it became this research grade observation. So if you were out in the field, now that you've attracted, let's say we're later in the summer and you've planted all the wonderful things Sue recommended, and you've got other native plants and a great pollinator garden, and you've attracted all these things and you want to document what's coming to your yard, as one example, by all means, go to nature preserves, go anywhere around New York for our purposes and help us identify native pollinators. But, you know, even these days, it's, you know, traveling is sort of, it's difficult and not recommended. And so you can contribute a lot to this project just by documenting pollinators in your local area and in your yard and local parks and things. So I highly recommend that you do that. If you are out there trying to document pollinators, I want to show you a couple of easy ways that you can contribute. I'm going to scroll all the way down again, and I'm going to go back to my observation page, and I'm going to click on this little plus sign. So let's say I'm out in Washington Park, which is my local city park in Albany, and I took a few pictures and then I want to submit those to iNaturalist. And I often do this in the field as I go. But in this case, I'm going to choose an image that's already on my phone. So I'm going to choose this image, and I'm going to choose not the pictures of the kite that I took yesterday, but I'm going to go choose, I got to pull it up. No, not the kite, not the kite. I'm going to choose this bug. And I know you can't see it yet. We'll look at it in a minute. Actually, no, let's look at it right now. So here it is. This is what I believe to be an eastern carpenter bee, not one of our focal bees. Pretty widespread, pretty well understood, but still, there it was, hanging out, posing for me. So I click on what did you see, and here's where the magic starts. This is the iNaturalist has an artificial intelligence-based identification tool that looks through all its huge database of photos and tries to find identified photos or photos with the species identified with similar characteristics to the one that you're submitting. And so when I tap on that, what did you see? It gives me suggestions. And they're pretty sure it's in the genus of large carpenter bees. And their suggestions include the eastern carpenter bee, which happens to be the only species in that genus in our area, and then some others that are sort of lookalikes. Well, I happen to know it was a large carpenter bee, so I can select, I happen to know it was an eastern carpenter bee, so I can select that. I can also compare it with these little arrows that are there. And so it's got its own photos, and I can scroll through its photos and compare that to the photo that I took and see if I think it's what they suggested. And in this case, I think so. I click that little checkbox. Look, I've got an eastern carpenter bee observation. It already has, from my photograph, it has the date I took it and the time. And because I've turned location services on in my camera of my phone, it will pull up the coordinates. Not everybody wants to do that. Not everybody wants Big Brother to know where they are at any given time. I like for Big Brother to know where I am at any given time so they know that I'm out documenting pollinators and saving nature. So I have my location services on my camera. It's a setting in the camera, and every phone's going to be different that way. So it pinpoints it exactly where. I tap on that and it shows me the location, and I can pull up the aerial photo and say, yes, that's where it was. Or if oh no, it was actually over here, I'm going to move this. So it's actually, that's where it was, and I can move it there. And, you know, it was somewhere around there. And so I can change the uncertainty, and I'm going to try to do this without knowing. Oh, I can zoom out and say, you know, it's somewhere in this patch of shrubs, but I'm not sure exactly where. So that circle is representing the area of uncertainty within which I'm sure I caught that bug. And yes, I'm going to discard changes. And then I just add it to our project. And so the very bottom says add to projects. I'm going to select the Empire State Native Pollinator Survey. We have a couple habitat fields we'd like you to fill out really quick. You'd say, oh, it was in a park, so I'm going to call it, here's like forest, open, wetland, different types. And I'm going to call it lawn, garden, landscaping. Check. And I would submit it by pressing that check mark, and I'm done. That's my observation. I'm not going to do it because I already
In the
submitted this
living room.
observation. So I'm going to discard changes to that. So that's the very straightforward, simple way that you can submit observations to our project using the iNaturalist app. If there's time and people are interested, I could show you the desktop version of iNaturalist 2. The desktop version is has some advantages over the app version. I think it's easier for those of us who grew up with computers as opposed to smartphones, probably to be able to look at photographs on a larger screen and really tell, you want to select your photographs and identify which ones are in best focus or show the angles you want. For me, that sort of sorting and thing is easier on a desktop. Or if I have a lot of photos to upload, so my SLR is an old Jeep SLR that doesn't have GPS coordinates attached to the photos. And so when I take photos with my SLR, I upload those to my desktop, and I do all my iNaturalist work on the desktop instead, because I have to select locations and go through maps and things. And I find that easier on the desktop. So if you have a lot of photos, you're bulk uploading, I'd recommend the desktop version. And it's a little easier to explore other people's observations that way too, at least for me. But some people are so used to their phones now that for just about everything, it's basically got all the functionality. You can actually edit photos, at least, you know, minor editing you can do within the iNaturalist app now. You can crop and you can zoom and you can lighten and darken. And really your goal is not to make an art piece, you know, and your goal is not to be on the cover. Well, your goal might be to be on the cover of Natural Geographic, but independent of that, your goal for submitting to this project is to submit a photo that's going to have the highest likelihood of resulting in a detection, you know, or an identification that's shared by multiple people. So, you know, you're not always trying for the best photo, and phones do a great job these days. The cameras built in smartphones are almost universally much better, you know, 100,000 times better than the point and shoot cameras of 20 years ago or 10 years ago even. So smartphones are great for better shots, closer up. SLRs are great, and you can stand at usually at a distance from the bug, which is helpful sometimes, depending on the bug and depending on the day. Some insects are so into what they're doing at a flower that they don't care that you're hovering right above them with your phone. Other ones might fly off if you get too close, and it's nicer to have a zoom lens. You can also buy zoom lenses for your smartphone. I have one that I screw onto a custom case, and it's just a 2-power zoom, but it does, you know, makes it twice as close. And I think that company, Moment, is the company. I think they make a 4-power zoom now too. So they're pricey as those things go. There's the clip-on lenses and things I haven't had great luck with, but certainly worth experimenting. So again, I'll take a breath and ask if you have questions about the iNaturalist process, and then we can play it by ear as to whether we want to look at the desktop version or not. So.
Is there anybody who has any questions for Merritt?
I do.
Okay, go ahead, Misty.
Hi. Matt, I don't know if you consider it kosher, but sometimes we have so many pollinators out there that we don't know if we're photographing the same specimen as it moves from one flower to another. And so what we've been doing is capturing them carefully and chilling them. Bumblebees, you have about, 30 seconds once they warm, then they warm up and they're gone. Except Stephen just caught a bumblebee in our living room. So we have to, seriously, so we're going to probably try to photograph it and release it, but it seems to be a safe way, and that way you can get headshots and you can get detailed shots. And with some of the smaller, the hoverflies and some of the others, you have about 2 minutes, 3 minutes, and then you can release them.
I love it, and I've done it a little bit myself and found it really helpful because bugs don't stand still all that often. And if you, on top of that, you have a windy day, God forbid. I mean, wind is just the enemy of an insect photographer, because even if the bug is sitting still, the plant is swaying back and forth, and it's really hard to get a good in focus shot. So I love the chilling idea. I'd love to hear how you do it. I've done it just with ice packs in a cooler, and I put them in a vial and I let them sit there for 20 minutes, and then they're cool enough that I can plop them down on a white cardboard or something and get some photos.
We usually use a colored background because white can trick things, and we use little condiment cups that you get in restaurants, and we save them. And we
pop them on top of ice or something?
No, we just put them in a cooler or put them in the refrigerator if they're here at the house for about an hour.
An hour in the fridge. Okay, yeah, that's great.
And it works well.
I had good luck with getting enough cooling to slow them way down or stop them for a little while with ice packs in a cooler, and they were in a pill bottle, and that cooled them down enough to that I could arrange them for photographs. But
it's easier to get them into the condiment cups because you can have a stiff piece of paper and slide them into the cup and then put the lid on carefully.
Okay.
By moving the paper out. And I'm cautious with bumblebees.
Yeah.
They sting multiple times. So
But I love being pollinated by them.
but, no, that seems to work very well.
Yeah.
And again, it's a problem because sometimes we get so many on some of the flowers, we don't know if it's the same specimen or not.
And that only matters because you don't want to waste your own time. It doesn't matter from a naturalist point of view that you've taken the same the same bug twice and submitted it twice. Even that's not going to hurt our project or iNaturalist data. It is still a valid observation. It's a different time. It's maybe a different flower, but you probably would want to focus on the diversity of things and the different numbers of species that you have. So
we just take a blank shot in between, like if we're doing specimen and it flies, we think, to another flower, just do a blank shot and then go continue on the flower, the
and
next
then
one
look
over.
and really look at wings and other things. Some of them will have little
Parts
parasites on them. Some will have tears in wings, and you have to sort of we compare them that way to see if we have the same specimen.
Great.
But we get rather niggly about it.
Cool this guy down.
Yeah. Steven's taking our bumblebee out to the kitchen.
So is there anyone else who has any questions for Matt or any of the other presenters? My chat box is pretty empty, so you covered everything very well, Matt. Thank you.
Or put everybody to sleep. It might be another.
No, I love the pictures of all the bees, and yeah, it was wonderful.
I will say something else, Heidi and Matt. One thing we've also been doing is finding the larvae or caterpillars of various sphinx moths and other moths and IDing them if we can, but we're also submitting those because they become adult pollinators.
Fantastic. Yeah. That's great. No, caterpillars of the moths would be, and I would say a larva of beetles would be great too, but it's pretty impossible to identify those.
Those are hard.
Yeah. I was going to stop sharing on this screen if I can figure out how to do it.
So if there's no other questions, thank you to everyone for joining us for the Indian River Lake Conservancy's first webinar. We hope that you can join us again tomorrow for Julie Hart, who will be talking about the Breeding Bird Atlas. So if you are a community science person, this is another webinar for you. And you can sign on, you can register for that by going to indianriverlakes.org and just checking under our events tab. And you can also find it on our Facebook page. So yeah, I just want to say thank you to everybody, especially to our presenters. What a great presentation, and we hope you all have a wonderful afternoon. And get outside and help the pollinators.
Thanks to all the Sues out there.
Yeah.
Thanks for listening, everyone.
Bye-bye, everybody. Thank you.
Bye,
Bye,
Sue.
thank you.
It's a great presentation, Matt. I really enjoyed
Yes.
it.
Thanks, Vicki. Great to see you and Steve.
We'll see you guys later. Bye-bye.
Bye.
Bye, thank you.